Hi everyone, this is Dr. Nimish Biloria from Hyperbody TU Delft, the Netherlands. I'm really happy and I'm quite proud that the Indian architects and builders invited me to present in this online conference. Just a little bit about my own background. I'm originally coming from India, and I did my bachelor's at the CEPT, Center for Environmental Planning and Technology in Ahmedabad, India. After which I went to the Architectural Association in London, where I specialized in the field of emergent technologies and design. And after which I was invited by the TU Delft to do a PhD there in the area of adaptive environments and adaptive corporate systems. After finishing my PhD, I'm currently working as an assistant professor and the research manager for my department, Hyperbody, at the TU Delft. And I'm particularly happy that this event is being organized today, and I'm being given this opportunity to present my lecture, which is titled Design Informatics. Why I'm particularly happy is that I'm really getting this wide platform, especially to talk about how the two fields of informatics and design can actually come together, and they are so synchronous in the manner in which they produce novel performative outputs. Throughout the lecture, I'll be actually referring to the word performance, and I'm also going to be talking about a lot of computational techniques and a lot of computational logics that run behind and present like a really logical underpinning to what design informatics and the idea of these two words coming together actually implies. Let me begin with a slide which actually outlines some of the current engagements at Hyperbody. If you look at the left corner, you'll see some input which we've been providing at Hyperbody since the last 4 to 5 years. It's a development in the area of new media as well as the idea of real-time interaction. Here we're dealing with the idea of how software tools and hardware systems can actually be coupled together in order to produce and not only design, conceive, as well as produce statistical data about urban formations, about architectural inputs, etc. On the right hand side, you'll also see some of our 1:1 built prototypes, which basically deal with the idea of, again, this notion of real-time interaction and what do spatial systems that perform in real time actually mean. Some of the projects that you see here, they are the muscle projects, which I'll be talking about in my lecture further. The bottom side, you see some of the projects which are done by our director, Professor Cas Oosterhuis, who's running a practice ONL in Rotterdam, Netherlands. The idea behind these constructs and the manner in which ONL, so the practice-oriented scenarios and how the education scenarios in terms of Hyperbodies actually couple together. So it's like a research and design endeavor which produce parametrically designed, really sophisticated build forms. I'll also be explaining about that. On this corner, you actually see one of our labs, which we call the building is known as iWeb. And the software which runs inside it, which I think just a simulated vision that you can see here, it's something to deal with the idea of multi-user and multimodal interaction. These aspects also I'll be explaining to you as we go further down the lecture. What's also interesting is when you start analyzing the idea of, okay, what is happening with the contemporary world? What is happening with the new designed entities today? We're again starting to deal with the idea of, okay, what paradigms in terms of theory, in terms of literature have been shifting and shaping this smooth, much more transient geometric entities that we're looking at. We're again trying to understand, okay, what does technology have to do with all of this in terms of developing new modeling techniques, developing new nerve-based technologies, etc. What role does programming, scripting, parametric logics, etc. have to play? And the entire idea behind the CAD and CAM integration, so the idea of how computer-based manufacturing can actually result in even such intricate entities like you can see here in terms of stereolithographic models, in terms of precision-oriented construction, till the point that everything is sort of, it's a perfectly fitting assemblage of elements together. So these issues are very much concurrent in today's contemporary scenario, which I'll also be elaborating upon. On the other hand, this entire issue of real-time interaction, or on the other hand, if you see this video on top, as well as this really famous project of Decoy, which is the responsive wall project, the entire idea of how material substrates, as well as the real-time interaction with your human self, can actually result in this case, the idea of music, or the idea of tonal variations in real time, because of the manner in which you step on top of this magic carpet, is something which is also equally perplexing at the same time. So I'll also be talking about this idea of real-time interaction by means of some of the interesting hyperbolic projects that we've been doing over the past few years. Our vision actually, it also leads to the point where we can actually think about buildings in themselves as interactive systems. What do buildings have to do in terms of continual data exchange with the environment, with the context that is around it, and how can this context or this information actually be composed in a manner that it communicates with the built form in order for the built form to augment itself in real time and therefore perform in real time, and therefore address not only contextual issues like, okay, how many people are surrounding it, or what are the environmental conditions, etc., etc. This issue, again, I'll be dealing with, and I'll be explaining it to you in greater detail. But in order to understand even the previous sections, or the idea of the new construction paradigms or the new technological possibilities that exist now, we have to understand the manner in which how multidimensional relational networks actually operate. What's really interesting in this fact is not only are we talking about the notion of multidimensionality in terms of, say, space, culture, economics, politics, etc., etc., but we're also trying to understand the relational intensities between these, say, for instance, in this case, different nodes, which can also be denoted as different species, different topologies, different spatial paradigms. So the underlying structure or the underlying logic behind this actually runs much more deeper in a manner that we start understanding a system's logic behind all of this. So the entire built form now actually becomes nothing else but a systemic entity which you try to understand via these two definitions. So if you look at the top definition, where it tries to understand a system as an assemblage of interrelated elements which comprises a unified whole and which facilitates the flow of information, matter, or energy, or the definition that is below, which talks about a system being a set of entities which interact and from which a mathematical model can often be constructed. The mathematical model in this term can actually also be in the form of scripts or codes, etc., etc. But what's of central importance in both of these definitions is the term underneath, the idea of interconnections and interdependence, or in other words, the idea of relationality between no matter what entities you look at. So you can talk about building components being related in particular manners, you can talk about social phenomena being related in a particular manner with the built form, etc., etc. Now, to elaborate upon this further, we don't really have to look much further. Even if we look back and try to understand how biological systems work, say for instance in the case above, if you look at and try to understand the manner in which this plant system, which is the Venus flytrap, actually has a kinetic mechanism by which it can open and close its flaps in real time because of the manner in which an insect can trigger one of the hairs which is standing on top of the leaf structure here. It's really interesting that all these phenomena like cell growth, mutation, turgor pressure, osmosis, etc., and the manner in which cellular tissues, or say for instance, if you look at that figure, the basic component of that leaf, a cell, can actually be triggered in a fashion that the outer surface of the leaf and the cellular tissue that forms this outer surface can gain maximum amount of water intake, because of which the outer surface actually expands and the inner surface doesn't, because of which the kinetic behavior can actually take place in real time. That itself is a really good example of how a self-sustaining system actually operates in real time. In the mechanical world, there have been various parallels. We have been developing the idea of, okay, microcontrollers, microchips. We have been also working with the idea of actuating systems in this case, or the idea of embedded computational logics, or even the idea of how material formations actually, or in this case, how can multi-directional fiber weaves can actually create a lot of difference in the manner in which structures can actually